Now let's take a look at another method of solving quadratic equations called completing the square. And in order to describe the steps in using this method, I think we'll go through an example. So let's go ahead and solve the quadratic equation 3y squared minus 5y minus 2 equals 0. Previously, we saw that we can solve this quadratic equation using the quadratic formula. And in this example, we'll see how to use the method called completing the square. There are a couple different ways to view the method of completing the square. There's a geometric way and an algebraic way. Personally, I find the geometric way to be easier to understand, but I will show you both ways. Now, in order to use either of the ways for completing the square, we have to have a quadratic equation of the form 1 times y squared minus something times y equals something, where these somethings are numbers. So two things have to happen. We have to have a 1 multiplying the y squared. We have to have the term without a y on the other side. So the setup of the method of completing the square is a little bit different than the previous methods. So in order to make sure that we have this form, I'm going to take my quadratic equation, I'm going to add 2 to both sides and divide by 3. So then I would get y squared minus 5/3 y is equal to 2/3. Once it's in this form, we can start with the completing the square solution method. I'm going to start with the geometric solution method, and then we'll talk a bit about the algebraic method. So if you want to do this by completing the square using the geometric method, the first thing we're going to do is form a geometric problem. This happens quite a bit in mathematics. You take some problem that is algebraic and you try to find a way to visualize it. So what we're going to do here is we're going to notice that this y squared is the area of a square with side length y. So essentially, if you have a square and it has side length y, then y squared represents the area of that particular square. Now, this next term, minus 5/3 y, that is the area of a rectangle, and the rectangle would have one length equal to y and the other one negative 5/3. And I understand it's a bit odd to have a negative length for a rectangle, but it turns out that that won't give us any problems later on. Just accept that it's a bit strange and let's work from there. So that being said, notice that this second shape here, let's call this the first shape. This second shape has area length times height, or width times height, or however you want to remember it, which would be negative 5/3 times y. And if you add these two areas, then you get the expression that's on the left-hand side. So the area of shape 1 and shape 2 is y squared minus 5/3 y. And so we can rephrase this problem, this equation of y squared minus 5/3 y equals 2/3 in a geometric way. And that geometric way would be find y. So the area of shape 1 plus the area of shape 2 equals 2/3. So again, area of shape 1 plus area of shape 2, that gives us the left-hand side, and we want to find y so that that area is 2/3. So visually what we have is we have the area of this particular shape, this particular square, which has side lengths y, plus, and I'm going to draw the second shape, that's shape 1 here, shape 2, alongside of it. So shape 2, if we take a look here, one of the side lengths is y, so one side length will match up with the square side length. So this here matches up with the square side length. And then the other length will not match up. That will be -5/3. So there's my second shape, and we want the area of this shape to be equal to 2/3. So all this is a geometric reformulation of the algebraic equation that we had earlier, y squared minus 5/3 y equals 2/3. Now because I'm cutting this in half, the side length of each of the smaller rectangles that are made will be half of the side length here. Let's draw what that would look like. So we'll have a square, side length y, then we'll have half of that rectangle that we had earlier, and this length has to be 1/2 of -5/3. So 1/2 of -5/3 is -5/3 divided by 2, which is -5/6. And this is not 6. I'm not sure why I put that. It is y. Then we have that other rectangle that we rotated and put up top. The top length here will be y, and this will be -5/6, this other length. And the area of this still has to be equal to +2/3. Because I didn't change the area of my shape on the left-hand side, so it still needs to be +2/3. Now notice I am going to clean up a little bit of the work so this looks a little nicer. On the left-hand side, we almost have a square drawn. I erased this work, but I have to change this to -5/6 here, there. We almost have a square drawn. This side length is y, and then plus -5/6, and this vertical side length is y plus -5/6, but the square is missing a piece. It's missing this top right-hand corner piece. So what I'm going to do is I'm just going to add it in, because remember the main idea that I stated was we're going to try to make a square out of this. And this is what you'll do every time. You'll make a geometric statement that says that the length, or excuse me, the area of this square, which will be the first shape, that will be, or perhaps better said, the shape labeled 1 in this picture, which has side length equal to whatever the variable you are solving for is. In this case, we're solving for y. And then you're going to create a rectangle, and its side lengths will be whatever is here and whatever is here. So some number times y. And it's okay if this is a negative. That's, again, it doesn't make sense in terms of area, but we can still do the operations and we'll still get a result. And then finally, you're going to say the area of that shape is equal to whatever the right-hand side is. And I think it's worth noting that if the right-hand side is negative, that's okay as well. So if this was a -2/3, we would have put negative here. Again, area being negative may look strange, but everything works out. So now that we have our picture drawn and we have an idea about how to set up pictures for other problems as well, let's talk about how to use this geometric problem to solve our original equation, because, well, that's what we want to do. The general idea is I want to rearrange this shape on the left-hand side into a square. So in order to do that, what I'll do is I'm going to cut shape 2 in half, and I'm going to take the right half of it and move it to the top. The problem is I've added some area now. This piece has area. Previously, when I cut and moved pieces, I didn't add any area to the problem. However, now I've added area, but I can quantify exactly how much area I've added. This square that I've added in the upper right-hand corner has side length negative 5/6. And so the area that I added is negative 5/6 squared. And so since I've added area to the left-hand side, I'm going to add area to the right-hand side as well, negative 5/6 squared. And now this will become, let's see, 2/3 plus 25 over 36. And I'll get a common denominator by multiplying by 12. 12 times 2 is 24. 24 plus 25 is 49. So this now has to equal 49 over 36. And more specifically now, the area of this large square here has to be equal to 49 over 36. Now, what is the area of this large square? Well, the side length is y plus negative 5/6. So the area of that large square is y plus negative 5/6 squared, or in other words, y minus 5/6 squared. And so from looking at our problem geometrically and rearranging the shapes a little bit, we arrive to an equation that says y minus 5/6 squared equals 49 over 36. This equation is quite easy to solve. Something squared equals a number. The solution to that will be whatever is here is plus or minus the square root of the right-hand side. And so y minus 5/6 has to be equal to plus or minus the square root of 49 over 36, which is plus or minus 7/6. Now we can go ahead and add 5/6 to both sides, and we get that y is 5/6 plus or minus the 7 over 6 term. And that's your answer. Now, I do think it's worth noting here that if you get to this point here, where you have something squared equals a number on the right-hand side, then it is important that this number is positive on the right-hand side. If you get a negative number, something like -1, then you're not going to have any solutions. And that's simply because you cannot take a number, square it, and get something negative. And then finally, if you get equal to 0, then you'll only get one solution. Because, well, let's imagine that we ended up with the equation y minus 5/6 squared equals 0. If you take plus or minus the square root of 0, you get y minus 5/6. The square root of 0 is 0. So this would be plus or minus 0, and negative 0 is the same as 0. And so y equals 5/6. So while it's not important when you are building your geometric problem if you get a negative for the length of a rectangle, it is important when you get to the stage where you start solving the equation that you have something squared equals a positive number or a 0. If you get a negative number on the right-hand side when you go to solve something squared equals a number, then you have no solutions. So if you got y minus 5/6 squared equals -1, we would say no solutions.